Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide for DTC P0135, which signifies an A-factor sensor, sensor 1, heater circuit malfunction, in the Honda Civic models from 2016 to 2021. The A-factor sensor, also known as the air-fuel ratio sensor, plays a crucial role in regulating the engine's air-fuel mixture to ensure optimal combustion efficiency and emissions control. This sensor is typically located upstream of the catalytic converter on the exhaust manifold. When the engine control module, ECM, detects an issue with the heater circuit of this sensor, it stores the DTC P0135 to indicate that the sensor's heater is not functioning as intended. Troubleshooting this code will involve checking the internal resistance of the sensor, investigating continuity, and examining wiring for any shorts or opens that could be causing the malfunction. Let's delve deeper into understanding the components and symptoms associated with this DTC. DTC P0135 is related to the malfunction of the air-fuel AF sensor, specifically its heater circuit. This sensor is positioned on the exhaust manifold and is crucial for measuring the air-fuel mixture post-combustion. It uses a heated element to ensure that the sensor can accurately read the exhaust gases under various temperature conditions. The heater's function is vital as it allows the sensor to reach optimal operating temperature quickly, thus enabling precise data to the engine control module, ECM. If the heater circuit fails, the sensor may provide erroneous readings, leading to poor engine performance and increased emissions. Identifying this malfunction early is key to maintaining emission standards and achieving better fuel economy. Multiple issues can lead to the setting of DTC P0135. A faulty A-finger sensor is a common cause. This could arise from wear or internal component failure. Additionally, poor electrical connections, such as loose or corroded terminals at the A-finger sensor, can impede functionality, making it essential to check these connections thoroughly. Damaged wiring or harness can also be a significant contributing factor, as shorts or open circuits disrupt the current flow necessary for the heater to operate. Addressing these possible causes involves visual inspections coupled with multimeter tests to ensure correct voltage and continuity throughout the wiring and connectors linked to the A-finger sensor. The occurrences of DTC P0135 usually manifest in several noticeable symptoms. One of the most immediate indicators is the illumination of the check engine light on the dashboard, signaling that the ECM has detected an issue. You may also experience poor engine performance, such as rough idling, hesitation during acceleration, or inappropriate air-fuel mixture that affects drivability. Increased emissions can result from a malfunctioning AF sensor, as it fails to correctly balance the air-fuel ratio, leading to higher pollution levels. Ultimately, ignoring these symptoms may result in further engine damage and increased repair costs. In the first troubleshooting step for DTC P0135, start by turning the vehicle to the on mode, which powers the onboard diagnostic system. Following this, use the Honda Diagnostic System, HDS, to clear any existing DTCs. This action refreshes the system and allows for accurate monitoring of current faults. After clearing the DTCs, start the engine to see if the code recurs. It is essential to check for both pending and confirmed DTCs with the HDS post-start. If DTC P0135 is still indicated, it confirms that the failure is ongoing, and you should proceed to the next troubleshooting step. If not, it suggests an intermittent issue that may not be present at that moment. The second troubleshooting step involves conducting a thorough diagnostic scan for any pending or confirmed DTCs using the HDS once more. It's important to check not only for DTC P0135, but also to be vigilant for any related DTCs such as P1658 or P1659, which can indicate malfunctions in the electric throttle control system, ETCS. If any of these additional codes are present, you will need to follow their respective troubleshooting protocols first. If there are no additional codes, proceed to the next step in the P0135 troubleshooting process, which will focus more specifically on electrical integrity tests for the sensor circuit. In this third step, turn the vehicle to the off lock mode before beginning the fuse inspection process. Locate fuse number A11, which is a 5-amp fuse situated within the underhood fuse relay box. This fuse plays a critical part in powering the AF sensor's heater circuit. Inspect the fuse visually for any signs of damage or a break in the filament. If the fuse appears intact, you will move on to the next troubleshooting step. However, if the fuse is blown, you need to address the cause of the blown fuse before replacing it and proceeding further in the diagnostic process. Now, for the fourth troubleshooting step, you'll want to begin by disconnecting the AF sensor, sensor 1, from its 6P connector. This disconnection is essential for safe measurement of the internal resistance values without interference from the circuit. Using a multimeter, measure the resistance between test points 1 and 2 of the AF sensor. Under normal conditions, the resistance should fall between 2.8 and 4.5 ohms at room temperature. If the readings fall within this range, you can proceed to the next step. However, should the readings deviate from this range, it indicates that the AF sensor is faulty and replacement will be necessary. In step 5, it's crucial to check for continuity between various terminal test points of the AF sensor and the vehicle's body ground. This test provides insight into the internal circuit integrity of the sensor. Perform continuity checks between the specified test points and body ground for AFHT, IGPS, LAF+, VCENT, IP, and VS terminals. Each of these terminals must show continuity for the circuit to function properly. If continuity exists, the internal circuit of the AF sensor is confirmed to be functional. On the other hand, if the continuity isn't confirmed, the sensor will likely need to be replaced due to internal failure. Step 6 involves additional continuity checks, specifically focusing on the AF sensor, sensor 1, database connectivity. This time, you'll measure continuity from the AF sensor to its 6P connector, particularly checking the VCENT, IP, and VS lines. The vehicle should remain in the off-lock mode throughout this procedure. Confirming continuity ensures there are no breaks within the wiring that might interrupt the signal flow to the engine control unit. If continuity checks yield positive results, move forward with the troubleshooting. Conversely, if continuity is absent, replacement of the sensor will be necessary due to compromised integrity. During the 7th troubleshooting step, you'll be tasked with checking for shorted wires in the AFHT line. Begin by jumping the SCS line using the HDS, which allows the system to assess diagnostic capabilities effectively. Wait for more than a minute before disconnecting the PCM connector E, which typically has 80 pins. Following this, measure the continuity between test point 1 on PCM connector E and body ground. A confirmed continuity indicates that there is a short in the AFHT wire between the AF sensor, sensor 1, and PCM. If this condition is met, repairs must be made to rectify the wiring issue. The 8th troubleshooting step involves checking for open wires in the AFHT line. This procedure necessitates checking continuity between test points while ensuring the vehicle is in the off-lock mode. The specific test points will include connections between the AF sensor, sensor 1, 6P connector, and the PCM connector E. If continuity exists when tested, it signifies that the wiring is intact and you can proceed to the next step. However, no continuity indicates an open circuit, requiring you to repair any faults found in the AFHT wire between the sensor and PCM. For troubleshooting step 9, set the vehicle to on mode to activate the electrical systems while ensuring the AF sensor 6P connector is still disconnected. Measure the voltage between test points specified in the diagnostic data, one from the AF sensor and the other connected to vehicle ground. If battery voltage is present, it confirms that the wires leading to the IGPS LAF Plus are functioning correctly. In this case, you should refer to authorized service information for further diagnostics related to DTCs. However, if no battery voltage is detected, it indicates that there is an open circuit in the IGPS LAF Plus line that requires repair. In the 10th and final troubleshooting step, you will begin by removing the glown number A11 5-amp fuse from its position in the underhood fuse relay box. This action is necessary to ensure safety as you check wiring for faults. After removing the blown fuse, disconnect both the AF sensor, Sensor 1, 6P connector and the evap canister vent shut valve connector, if applicable, specifically for USA and Canada models. Measure for continuity between the designated points to determine if a short exists in the IGPS LAF Plus line. If continuity is established, it indicates a probable repair in the wiring is needed, as it is compromising the circuit. Replace the blown fuse to finalize repairs. Upon completing all the troubleshooting steps successfully and performing any necessary repairs, you'll want to verify your repairs. Start this process by clearing any DTCs using the Honda Diagnostic System, HDS. Next, conduct a test drive of the vehicle under typical operating conditions to ensure everything is functioning as expected. Pay close attention to engine performance and monitor if the check engine light reactivates, indicating any persisting issues. Success in this step means that DTC P0135 should not return, confirming that the issue has been resolved and the AF sensor circuit is operating correctly. Preventive maintenance is vital in keeping the air-fuel ratio sensor circuitry functional and reliable. Regular inspections of the wiring harness connected to the A-factor sensor are crucial, since it is exposed to high temperatures and can degrade over time. Ensuring that connectors are free of corrosion and securely connected can prevent intermittent faults that may not trigger mechanical failures immediately, but can lead to suboptimal vehicle performance. If you identify any signs of wear, prompt replacement of faulty sensors can save you from more complicated issues down the road. Maintaining the integrity of your engine and the vehicle's emission system. In conclusion, DTC P0135 indicates a malfunction within the AF sensor heater circuit, and addressing this promptly is vital for maintaining engine efficiency and compliance with emission standards. The troubleshooting process emphasizes examining the sensor's condition, its connections, wiring integrity, and any related components, taking the time to ensure that connections are solid and that there are no shorts or opens along the circuit can prevent future issues from arising. Moreover, emphasizing preventive measures ensures the longevity of the components involved. Vigilance in maintenance and timely repairs can mitigate complex diagnostic challenges down the road, enhancing your vehicle's reliability and performance. Please like and subscribe to the channel. See you next time.